Assalamualaikum warahmatullahi wabarakatuh. My name is Haekal bin SHAHRIMAN, and today I will be presenting my group members in presenting our lab entitled AC Single Phase 2-Pole Synchronous Motor. So my other two group member is SYED HASSAN HUSSAIENI bin SYED OMAR and one SAFRAN AIMAN bin YAMIN. So firstly, we have been given tasks for each other. I will be presenting this simulation, and the other two will be completing the report, minutes of meeting, and editing the video. So first of all, let's start with the equipment used in this lab. So the first one is we'll be using single and three-phase measurement, and the second one is we'll be using variable AC/DC supply, and the next one is we will be using rectifier, voltmeter, and ammeter. And then we use voltmeter and DC voltmeter and ammeter. And then this part is what we call a universal power supply. And then we got the DC variable speed drive, and this is base unit of machine. And this one is the rotor. So next we'll proceed to the first activity. So first activity, we switch on the drive machine and bring the shaft speed to 3000 RPM in reverse mode, and then switch on the AC single phase supply to the stator windings and adjust the voltage level to 135 volt. And then we switch on the synchronous motor rotor DC supply and adjust the current to 2.5 MDC. The motor should pull into synchronism and run steadily at its synchronous speed. And then the drive machine can now be switched off, but as the shaft remain coupled to the synchronous motor, it will now be driven by it. And then we will obtain this result. As you can see here, at the stator part, the volt AC is 135 volt, and the MAC is 0.6. And at the rotor part, we obtain the volt DC at 5 volt and MDC at 2.5 ampere. And the shaft speed at 50 Hz frequency is at 2680 RPM. And then we proceed to the activity number 2. It's the same as activity 1, but with no shaft load. Vary the excitation current from 2 A until 8 A, and we need to observe the variation of the AC supply current to the stator current. And then tabulate the result in table. We use clamp meter to collect the measurement, and then we get this table. In this table, we can see when the IDC is increased from 2 A until 8 A, it will also increase the IAC, this table. As you can see here, a synchronous motor will achieve its unity as well, leading unity to operate. In this result, it operates in leading unity when the IDC is at 4.75 ampere. It excited the synchronous motor function at unity factor, which has its peak at 1 A. In conclusion, from this study, for ADC adjusting the excitation motor, the power factor will also be changed. This is shown as in this graph. I think that is all from me. Thank you.